Okay, so 100 test cases passed in that tiny amount of time it took this to run. And so one thing we could conclude is that since 100 tests passed over read all, that the logic is solid. But it turns out that this conclusion isn't really warranted. Let's see if we can get the program to tell us why. So all I'm going to do here is print out a value indicating the number of bytes that was actually read by the raw read system call. Now we'll run our testing loop. And what happens is, every single time we called read, it read the full size of the file. So our splay.py file here, we can see has 3,121 bytes, and the actual Unix read system call always read that many bytes every time we called it. So what ends up being the case is, even though it's legal for read to return less bytes than we asked it to read, it's not actually doing this. So what we're going to need to do in order to test our logic in any meaningful way is make it do that. And so the question is how to do that. Well, one way to do that would be to go and hack macOS so that sometimes it doesn't read all the bytes that we asked. And that is not very fun. So we're going to do something a little easier. We're going to insert faults ourselves by calling a read fault injection file, by calling a read function with fault injection. This is a function I already wrote here. So what you can see that read with fault injection does is it has exactly the same interface as read, just a different file name. But what it's going to do is instead of reading the n bytes that we asked for, it's going to set the number of bytes to read to be a random number between 1 and the number of bytes inclusive. And so the +1 there means that instead of going from 0 to the number of bytes minus 1, we're going to test the range from 1 to the number of bytes. And that's what we want to do. We don't want to return 0 because that indicates an end of file condition. So now we're ready to run some tests.